Welcome to the Weekly Squeak, your weekly geeky squeak with me, Christian Schiller. Recording today from a hotel room in Osaka, fresh out of the epic week that was DevCon, the kind of prime developer event for the Ethereum community. So I'm on my travel microphone, no pop shield or anything like that, in a hotel room with noisy air conditioning. So hopefully you can put up with me for a few minutes before I get to my interview to cover a few of the links that caught my attention this week amongst all the chaos that was DevCon. And my interview this week is with Leemon Baird from Hedera Hashgraph, a sort of a blockchain. We will get to that a little later. But first, here are my links. So I was stupid enough to install macOS Catalina. It's a little bit of a trash fire. I'm getting there. I'm struggling. There's quite a few things that don't work. I'm not quite sure why I didn't heed the notice. I am an upgrade junkie. I could not stop myself. But on the more positive side, one of the features that came through, and this is a story from Mac Stories written by Stephen Aquino, Hello Computer inside Apple's voice control. Apple has always been quite good with accessibility, but it really upped the game in Catalina. It's one of the features that actually works very well and has opened doors for lots of people. And it's always interesting with Apple how people sometimes overlook these features that are not the headline features, but are actually very good features. And this enables people to do pretty much anything they want by voice control with their Mac. It's mostly aimed at people who cannot use their hands or arms very well on a keyboard or a mouse, or especially on a mouse, and want to control input with voice. I mean, you could use it to speak to your computer if you wanted to, but not necessarily aimed at people who have other options. And it's a really nice coverage and also discussion with some of the engineers behind the particular component about how they created it and how they tested it and things like that, and how it interacts with other accessibility tools as well. So actually, in amidst all the chaotic features that don't work very well, voice control in Catalina is working very well and making a lot of people not only happy, but able to actually use computers effectively for the first time in a long time, by default without additional software. So really nice. Have a read the article and have an experiment with it to see how sometimes it's good, especially as web designers and application designers, to see how some people have to use your applications. And then you start to redesign and rethink how you design your applications for people with those use cases. On the more negative side of things, continuing the story of Richard Stallman, which I covered last week, the fallout continues. This is an article specifically on the Business Insider from Julie Port. And this covers how many dozens of programmers from the GNU operating system, or the GNU projects, have also, he kind of officially stepped down from MIT and sort of the EFF, but not GNU. And a lot of developers on the GNU project have said, well, we don't want to be involved with this if he's still here. And this is kind of one of these interesting things. It's definitely his project. The others, it could be argued, that have sort of been spearheaded by other people for some time. GNU has kind of still been his baby, as it was. So, there's been a lot of backlash against the fact that he hasn't officially stepped down. And could it be that he will, or will the GNU project collapse without a sort of benevolent-ish, shall we say now, dictator? Time will tell. The fallout continues, and I think it's interesting to show that if you have unacceptable opinions in this modern era, then it doesn't really matter who you are. People will not necessarily want to work with you anymore, and I think that's also a strong sign to see that, it doesn't really matter how famous, how important, in quote marks, you are. If your opinions come out as being unacceptable, then that is it, and that is, I guess, a good thing. And good to see that developers standing up for bad attitudes and inappropriate attitudes finally, and having the strength and to do that. And sometimes it takes one person to start a kind of a waterfall, but it's good to see that at least developers are now starting to be able to do that more and not have this kind of concern over, well, this person is too big to bring down. They're actually not. So the story continues. We shall keep a close eye to see how much more it continues. I have actually got back on the writing train. I haven't necessarily been promoting my articles, but you can still find what I've been working on at dzone.com or on my personal website at christianschiller.com/writing. But one of the tools I covered recently was Micro K8s and the MicroPass. There's 2 applications from Canonical for running Kubernetes clusters on a local machine. I did a fairly short roundup of it, but then I came across this post on IT Next from Luigi Corsello, who goes into a lot more detail of using it. So if you kind of read my article and want to go a bit further, then you can have a read of his and get a bit more detail. And especially if you're interested in diving into the world of Kubernetes, but don't really want to get into kind of creating complex clusters from the outset, it's a really good way of getting started with sort of 5 to 10 minutes and having a working Kubernetes installation. Not really a cluster, that's kind of the point, but and then roll it out from development to production from there. So if you want to dig a bit more, have a read of that article after you've read mine, please. Rounding off the episode with some role-playing news. So this is an old post from Gizmodo, Ed Grabianowski, from 2015. But I have been playing Call of Cthulhu, the role-play game inspired by H.P. Lovecraft, another controversial character, shall we say, but one who is long gone. And I guess because of that, this article popped up in my feed. Call of Cthulhu was the first role-playing game to drive people insane. This literally always happens. Someone always goes insane or less often dies in Call of Cthulhu. But the article goes into how, now into its 7th edition, just recently, it was one of the first games to kind of move beyond just D&D style hack and slash. And I'm not actually 100% sure if that's strictly true, but from 1981, I guess it's going to be reasonably accurate. Other more knowledgeable role-playing nerds may be able to correct that. But yeah, it goes into explaining why that's different, why that was important, some of the really in-depth campaigns that came out around that time, like Masks of, here we go, ready for the pronunciation, Nyarlathotep. I should really know better. I'm not sure if that was correct. And also things like Mansions of Madness. And then how the game inspired spin-offs of it, like Trail of Cthulhu, which is a sort of pulp fiction style version, and even Cthulhu Live, which I've had for some time and wanted to play. It's a challenging game to play, actually. It's not always that easy, but it's certainly one that's worth trying if you feel like leveling up your game, literally, to something slightly different and slightly more subtle than Dungeons & Dragons. And finally, horror and role-playing. This is from Ars Technica, but it was, again, widely reported. This is particularly from Sam Makovich on Ars Technica. Wendys, the American burger chain, released a role-play game for some strange reason called Feast of Legends. It's basically a very simplified D&D where you play certain characters and you fight evil creatures, but they're all related to Wendys somehow. So you have Order of the Beef, Order of the Chicken, Order of the Sides, and things like fighting frozen food, which I guess is one of Wendy's marketing tactics. I don't really know. I don't really eat meat, and I don't live in America, so I'm not 100% sure. I guess it's a marketing campaign aiming at a particular section of their audience. I read through some of the free PDF. It's actually not too bad. It's actually fairly well written, so that's good too. There are some Twitch games you can go and watch, but download it and play with your own gaming table and see how you go. I'm not 100% sure how deep you'll be able to go into this world, but I am sure, if not already, people are writing adventures for Feast of Legends. Will we get to a 2nd edition? Will we see as many editions as Call of Cthulhu or D&D? Time will tell. And now, here's my interview with Leemon Baird when we talk about Hedera Hashgraph, the not a blockchain.
So I'm Leemon Baird, and I'm the chief scientist and CTO at Hedera. And Hedera is a public network that had our big open access a couple weeks ago, and now the world is able to use Hedera, and they're using it.
And what is Hedera? We'll tread carefully here about what terms you want to use to describe it.
Sure. So it is a DLT, a distributed ledger technology. It is a public ledger. The way some people use the words, it's a blockchain, although it's not actually a chain of blocks. So I would say it's a DLT that isn't a blockchain. But, you know, if you use blockchain in the generic sense, then it's a blockchain. The point is, it's a public ledger. It's a group of computers that are coming to agreement. They computers have guarantees that they will reach agreement. They reach agreement quickly on the ordering of things. And that means you can use it for cryptocurrency and for files and for smart contracts. And we'll be soon adding a fourth service as well. So it is a public ledger.
And let's just dig into that a little bit more, because it is one of these areas that always confuses people. DLT, and now I've had a complete blank of what that stands for, even though you just said it. Distributed ledger technology. That's it. Yes.
Yeah.
Blockchains often will get grouped underneath that, along with other things that have some related heritage. But in the Hedera Hashgraph case, what actually is yours then? What is your DLT? How does it function conceptually?
So to the user, it's all DLTs sort of function the same. You submit transactions to them to transfer cryptocurrency or to run a smart contract or to store a file. And the computers as a whole, in the whole group, as a community, come to an agreement on what to do, and then they do it. And you don't have to trust any one computer. You just have to trust that, most of them are good, or more than 2/3 of them are good. And if you can trust that, then you can 100% trust that your transfer really did go through, and, your file won't be deleted illegally or whatever. You have trust that not too many of them are bad, and it amplifies that to trust that you can absolutely believe what it's doing. You don't have to trust any single computer. So from the user's point of view, that is what a DLT, or people would say blockchain, is, as opposed to a single server where you have to trust the guy running the server. That would not have the same kind of trust.
And this actually gets into this interesting point. It's one I remember discussing with Hyperledger for similar sorts of reasons, especially when you get private DLT/blockchain. What you just described, what is the difference between it and a more traditional distributed system, potentially with transactional support that would also kind of have the same guarantees? What would be the fundamental differences?
The fundamental differences between a DLT and a traditional server, like a traditional database?
Yeah, with consensus algorithms, traditional consensus algorithms, and like Raft and Paxos and things like that.
Oh, those are traditional. Yes, I understand.
Yeah.
So many of these traditional algorithms are not ABFT. Mm-hmm. They don't have as high a level of security, so your trust would not be as much. If they are not asynchronous Byzantine fault tolerant, that means that they don't have certain kinds of trust that you would have otherwise. Many of them can be shut down with a DDoS attack, a distributed denial of service attack. And so you would have to worry about that. Can the whole network be shut down by shutting down one computer? And to be clear, just like I said with the trust, it's not a panacea. If somebody can shut down all your computers, then your ledger goes down. Mm-hmm. But you would hope at least that you could survive them shutting down one computer at a time. And so for some of these leader-based systems, like you were mentioning, you have problems that if you shut down the leader, then the whole network goes down. And you could say, well, we'll just get a new leader. Yeah, but then they could attack the new leader. Or maybe you have a round robin where you change leaders every couple seconds. Well, if they know who the leader is at every moment, they can always be attacking the current leader. So having ABFT is better than merely BFT. And then some of these ledgers aren't even BFT. For example, some of them never have finality. You never know for sure that your transfer has gone through. You just become a little bit more sure and a little bit more sure over time. And, after 6 confirmations, you say, well, I feel sure enough. But it could still revert. You never really know. If it's BFT, then you know for sure at some point. So that's it. You get finality and you get this DDoS resilience if you're ABFT. So that's some ways in which it is better. It also has some performance and better improvements as well.
The other aspect that was mentioned to me, and I wonder if this relates to Hashgraph, is the aspect that with a traditional distributed database, and I use the word traditional fairly loosely because they're not that old, but in technical terms, they're fairly old. The trust mechanism is the interesting aspect too, in that generally someone configures the access rights, gives access to particular systems, et cetera, whereas with a DLT or a private blockchain network, also the trust is defined by an algorithm, and then the trust is passed out by the algorithm, not by an administrator or a developer or a DevOps person. And is that also true with Hashgraph?
Oh, absolutely.
Yeah.
So for a public ledger, the trust is I trust that I'm not going to have a large number of the participants colluding together to hurt me. Any public ledger will hurt you if a large number of them collude to hurt you. But you don't have to trust any single one. People sometimes call it trustless, which is maybe a little bit misleading. But what they mean by trustless is there's no one single person involved that you have to trust. Whereas with a database, well, the person who runs the database can do anything. They can change the data. They can cheat. They can, if it's cryptocurrency, they could just print new money out of thin air. They can do anything they want. And you have to trust that one person entirely. But with a ledger, the only level of trust you need is just to trust that you're not going to have a large number of the community colluding to gang up on you. You never have to trust any single person. And that's a huge difference. And so, yeah, the database world has had multi-party databases, for decades. But one malicious party could damage the whole system. And the whole point of ledgers is that you have a better trust model than that.
So let's dig a little bit more. So I think you mentioned it, but I just want to clarify. It's a fully public network?
So there's public and permissionless are two different concepts.
Okay.
It is fully public.
Yeah.
Public means anyone can use it without permission. Mm-hmm. Permissionless means anybody can run a node without permission. Mm-hmm. So what we have is on the public versus private, we're fully public. As of 2 weeks ago, we just had an open access where we're now anybody can use it. You don't have to tell us who you are. You don't have to get permission from somebody. You don't have to sign up for something. Anybody can submit transactions. That's what a public network is. Then for the nodes themselves, if you want to run one of the nodes on the network on the mainnet, then at the moment you have to have permission, and that will transition over time to being permissionless, where anybody can run a node anonymously without having permission. And so that's the path that we're on right now. And right now we have the council members to build trust in this permissioned system. And then as we can afford to go to proof of stake and be able to trust that no one bad guy can get too many of the tokens, then we will transition to permissionless, where anybody can run anonymous nodes. So that's the path that it is on for permissioned versus permissionless, but it is public right now.
And so despite being a public DLT, you do claim, much better performance numbers over a lot of other public blockchain / DLTs. How are you accomplishing that?
Yeah, so for doing transactions, the cryptocurrency, we started at 10,000, and we'll raise that limit over time. But right now we started at just 10,000 a second. And that's pretty fast. 10,000 a second isn't bad, but we'll go a lot faster over time. The reason we're able to do that is several different things. First, the Hashgraph algorithm itself is just inherently efficient in its use of bandwidth, and it inherently comes to a consensus very quickly. And so, it just works very well. The fact that we are storing a state rather than having to search through the whole history when we process a transaction, we can just kind of remember the current balances of everything, and we're just updating a state. Helps with the efficiency. And then there are a number of things that we do with the mirror nodes where they hold the whole history, and you can go to mirror nodes, but that's sort of a separate network that is fed into from the mainnet. And so we're able to do it very fast in that way. And that's how we can be fast in a single network. Now, there's another way of scaling, of course, which is to be fast at layer 2 or with side chains or with other solutions. And we have a different way of doing that as well. We can talk about that. But to be fast in the single network is just because it has Hashgraph at its core.
Yeah.
And
actually, that storing state thing is something that just got my attention there. Because I was about to ask about, the benefits of DLTs and blockchains is often this immutability to be able to see how a state was accomplished. And if you're only storing state, how do you do that? And you did answer that. But this does start to sound comparable to, in the blockchain world, things like sidechains or the ready proposals for sidechains, but also in more, again, in quote marks, traditional distributed systems with things like event stores or state stores, where you don't keep everything in the kind of the performance focused system, you keep the most important state and then kind of how to find the state that came before that if needed. When in most cases you possibly don't. So why store it all? But a lot of people will want that immutability. So if someone does want to rewind to find that steps that got to state, is that also as performant, or is that likely to be a bit longer?
So what we have there is the same throughput, but we have a little bit longer latency. So instead of a few seconds, you maybe add 10 seconds or whatever to that.
Okay.
And that's in our current mirror nodes. As we improve the mirror nodes, we will be able to make those faster in latency as well. The mirror nodes are currently released open source. People are running them. We're running a mirror node, and I think other people are starting to run mirror nodes. So for people who want to look at the history, we have that. And the mirror nodes are looking at a history that was digitally signed by the mainnet, so you can know that it's as trustworthy as the mainnet is. And so the mainnet itself doesn't have to store that history. And so we have separated that. So we've separated the current state from the history, and we're managing both of those. And already anybody can run a mirror node if they want to right now. Just get the software and run it. And this is an early alpha version of the mirror node. We'll be getting better versions as time comes on that have lower latency, but they'll have the same throughput as mainnet. That is the equivalent of separating state from history. It is not the equivalent of a sidechain or a layer 2 solution. Yeah. And we have something that is analogous to that, but different in many ways than most sidechains and layer 2 things in our Hedera consensus service, HCS. And that will be coming soon. And we've talked about that. And we have a beta version of it running, but we'll be releasing that soon.
Okay. Now, halfway down your webpage, I saw a list of companies. It said running Hedera, which attracted my attention because amongst some that sounded sort of more crypto focused were a few like Boeing, Deutsche Telekom, IBM. I clicked on that, and it turned out they're actually what you call council members. So what do you mean by running, and what is a council member? What is their function in the network?
Yes. So Hedera has a different governance model. Hedera, as an entity, as a legal entity, is owned by the council members and is controlled by the council members. This isn't just an advisory board. They actually own Hedera. They are Hedera. And we are growing. We have 10 right now. We're going to have 39. The plan is to stop at 39. And so we're growing. You mentioned some of the names that we have. And they joined the council. They own a piece of Hedera. They come to periodic meetings and make decisions on what Hedera will do. So they will make decisions on things like the roadmap for features being added and how to manage the treasury, all of those sorts of decisions to bring hopefully good governance to it. But we've also ensured that they are very diverse. So they're spread around the world. They're not all under one government. They're in different sectors, different industries. So they're not all, they kind of keep checks on each other and balance each other. And they have diversity of views on things. They come from different cultures and so on. So we have a diversity of them, but they are, as you mentioned, large companies. They're IBM and Tata and Boeing and Deutsche Telekom is the biggest telecom in Europe. We have these very big ones. Magazine Luiza, Magalu is the biggest or one of the biggest retailers in Latin America. We have very large entities involved here. Nomura is one of the largest banks in Japan. And so they run Hedera, making decisions for Hedera. In addition, I told you about this path from permission to permissionless. The initial nodes are also run by them. Eventually, we'll have anonymous people around the world to be running nodes. But to start with, we're having the council running the nodes. And then we will go along this path where then other people can run nodes that we have allowed, that we trust. And then we'll go beyond that to where anyone can run a node anonymously without telling us and so on. But to start with, they're running the nodes, but they're also the governors. And that's the real purpose, is the governing.
And this is now seems to be the path followed by quite a lot of the new DLT technologies, is to start with a couple of key players and then hopefully add the public ability in the future. So, and some of that is hopefully going to happen, because otherwise what alternative are we creating? it's kind of not massively different from running a cloud service or something if only certain people are allowed to run components of it. What's needed? What's the next steps needed to open that ability to anybody, and how will you have a completely open process, or will there be certain stipulations people have to meet?
No, it'll be open. It'll take a while though, for security reasons. Now there is actually, even at the moment, you can say that having, say, council members running nodes is better than having a cloud service where one company is running all the nodes. Because if one company runs all the nodes, you have to trust the one company. Right. So it comes back to the trust model. If these big multi-billion-dollar companies around the world, do you think that one of them might compromise their reputation to attack you? Well, maybe. Do you think a full third of them will? That's less likely. I mean, you can trust it more. So we do have a trust model here, I think, that works even with just 10 council members, works better with 39. And then, as you say, it's even better as we go along this path to where anyone in the world can run a node. And the goal there is that you would not have to say who you are or anything. You would just have to say, you'd submit a transaction saying, I want to run a node. And here is my account, because you're going to pay me to run a node. Here's where I want you to send the HBARs to have me run a node. And here's my IP address so people can connect to me so I can connect to the network. And that's it. You don't say who you are. You don't get permission. You just automatically do it. That would be the end goal. However, to be safe, we have to make sure that the proof of stake system is secure at every point along the road. And so that's the important thing that gates the timing of all this, is the proof of stake system. And we can talk about that. But that's the ultimate goal.
Yeah. And how interestingly, for projects like yourself that sort of doing this in a phased approach, which maybe some of the public networks, the sort of early public networks that let it open to anybody should have tried to do somehow as well. Distributed systems generally have always been a struggle to test at scale, but how will you test that adding more and more council members, if you like, is viable and won't break the consensus algorithm?
Okay, so the consensus algorithm itself has math proofs.
Yeah.
And the math proofs have actually been checked by a computer. Very few systems have math proofs, and those that do, very few of those have been actually checked by a computer, which we have done. So the algorithm itself looks fine. Then as for practically, can we go from 10 to 39? Will it break? Well, we've tried 39 nodes and they work. Could we go to 100 nodes? Could we go to, even more? Well, we've tried it and it worked. So I think that practically it will work. As we get to closer to where we can afford to have millions of computers around the world running this and be secure, we will, of course, be testing with larger and larger numbers. But it would be kind of stupid to put 1 million computers in one shard. That's a waste of resources. Yeah. As we get lots of computers, we'll go to multiple shards because you get lots of advantages from sharding. And so no one shard will be huge, but we'll go to sharding. But we really can't do that until the crypto economics allow you to do proof of stake securely. And so that will be the next step.
And do you mean sharding in the again, quote unquote, traditional distributed sense? Or does it mean something slightly different in Hashgraph?
So in Hashgraph, it's the same.
Okay.
Sharding.
I keep saying Hashgraph for some reason, and I don't know why. And I just realized there is no I. I don't know where I made that up from.
Oh, yeah. Oh, that's fine. Yep.
Sorry. Sorry. Please carry on.
Oh, no, that's great. So in Hashgraph, it is the same concept. The concept is that, what you have are not just one group of computers all talking to each other, all sharing the same data, but you have multiple groups. And each group has its own data, and they talk within the group to maintain its own grade. It's sort of like multiple ledgers, like multiple blockchains. But we don't call that multiple blockchains or multiple ledgers because they communicate with each other. And so for a sharded system, you have a way that they can communicate with each other. So, for example, you might have a cryptocurrency account with some HBARs in it, and I would have a cryptocurrency account with HBARs. They might be stored in different shards. And so my shard only knows about one shard only knows about my account, and one shard only knows about your account. And then when we transfer HBARs from yours to mine or vice versa, the two shards have to talk to each other. And in a lot of systems, if you don't have math proofs that the underlying algorithm is ABFT, then of course the big sharded system is even less likely to be ABFT. But in our system, the underlying one has these security proofs. And so it is possible to have inter-shard communication in such a way that the proofs still hold, that you still have a guaranteed asynchronous Byzantine fault tolerance for the whole multi-sharded system, as long as you trust that there's no large fraction of a shard that will be ganging up on you. Same kind of trust model as we talked about before.
Okay. Let's get into, we've talked about how the network is running at an infrastructure level and also a consensus level. So now I'm having a look at the list of applications that people are building, and we get kind of to the sort of somewhat typical list of use cases we tend to see on DLT and blockchain projects, which is fine. I mean, I think that's realistic. But yeah, what are the sorts of applications and use cases people are using Hashgraph for at the moment?
Yeah. So it is what you're talking about, the traditional things based on cryptocurrency payments or on smart contracts and storing information and collaboration between people in various ways. A lot of the use cases that you've talked about. But we also have some that are starting to move towards, in some ways, new kinds of things, like you have ad stacks built on us. And they deployed. We had a bunch that deployed even on day one. Now, when we turned on open access, a whole bunch were already running. Ad stacks is one of them. And what it does is it deals with tracking what's going on in advertising, and you keep track of lots of little tiny things that happen. And what they do is they bundle them together into sort of summaries that they then put into transactions, cryptocurrency transactions that go through the network. And so you talked about how having this history is important, and our mirror nodes keep the history. That's really what they're doing. They're doing these cryptocurrency transfers, not really to transfer cryptocurrency, but because they want to be storing a record of what happened. That is actually moving closer to our Hedera consensus service. They're really using our cryptocurrency as if it were the HCS, where the idea is you use the ledger to put things in order, to keep a record of them, and to do it very fast. And that is what you're really using it for. But the actual processing of thinking about it, you do in a separate computer or a separate set of computers. This is a little bit different from a traditional sidechain in that you can have the trust of the big one entirely. You don't have to trust anybody in the little one. Whereas with a sidechain, you kind of have to have some trust in the computers running the little one as well. So ad stacks is an application doing that. But we have others, lots of different, over 1,000 dApp developers have told us they're building on top of us. We have a few dozen that have now deployed on us and are running. And then we have the council members. They have applications of their own. And we're talking with them about building their applications. And again, a lot of theirs have this HCS feel to it. We're starting to get the impression that for a lot of the big developers, what they're really interested in is having the speed and privacy of a private network, but they want to have the trust of a big public network. And so the HCS allows you to do that. You have the privacy of a private network, but you don't have to trust any of the computers in the private network, or just one, and you run that one. And all of your trust comes down to having to trust the public network. And so that's a lot of what we're hearing about from even our council members and some of our big people we're talking to that are interested in building big applications.
And I could certainly see there's a lot of the trust aspect in some of these applications, things like logistics, checking healthcare, providence, identity records. The one that catches my eye, because I know I've heard this is something that's a problem in general software development world, especially the open source world, is the thing about binary validation. This is Binsignia. I know a few people who've tried this in the kind of blockchain crypto world, but nothing's quite has quite taken hold yet. But it's sort of obviously a fairly one that's fairly close to the community, I guess. Anyway, that's just one that caught my eye in particular.
Yeah, there's a lot of them. And a lot of them come down to there's information we want to store in a way where everyone in the world sees it and everyone knows that everyone else is seeing the same thing. And you know it's not going to change except in the way that it should change. You could call it immutability or you could call it controlled mutability. but it's making sure things don't change unless they're supposed to change. A lot of them have this in common. People are talking about recording assets and recording ownership and recording history and provenance, provenance of drugs or provenance of food, where it came from, trying to prevent blood diamonds by saying, well, where did that diamond come from? And you track it all the way along. People talking about using it for auditing kinds of things, where you put an audit trail in it and you can guarantee to the auditors, hey, I didn't go back and change history. Those are things that people are interested in. And then also, where people are interacting with each other. So you can be buying and selling things, or you can be doing markets or auctions or whatever, those sorts of things. I think that these are all good applications, and people seem to be interested in them.
And how many of these are currently in that sort of proof of concept stage versus live as many applications on blockchains and DLTs are applications?
Yeah. So we have a few dozen that are live that are actually running on the network right now, smart contracts that are running on the network, and people like AdStack that are using the cryptocurrency transfers as a way of recording data. Those are live right now. There's also some applications built on the file system. So those things are live right now, a few dozen. We have a whole bunch that are still in the POC stage, and we're excited to see where it goes. We just started open access, and people are using it, and I'm just really excited to see where they're all going to go.
Actually, you just mentioned something there I forgot to dig into, so it gives me an excuse now. Let's talk about how developers can actually build on top of Hashgraph. I can definitely see you have SDKs. You mentioned in passing their smart contracts, but I don't see any mention of a smart contract language. So is it one of these?
Solidity.
Oh, you are using Solidity. Okay.
Yeah.
All right.
Yeah.
Okay.
And we've taken smart contracts that ran on other platforms and ran it on ours, and it works fine.
Okay. Okay.
Yeah.
So the SDK is for what purposes?
So we have an SDK that allows you to create and submit transactions to the network.
Okay.
So that would include moving cryptocurrency or creating a cryptocurrency account, calling a smart contract or deploying a smart contract, creating a file, deleting a file. It has a few little things that most ledgers don't have, but mostly it's the core things that you would expect a ledger to have, plus a few extra things that are kind of fun, like a revocation service and some other things that are kind of neat.
So if you've come from other, predominantly Ethereum world, but some others, even Libra to a certain extent has some similar concepts. It's not going to be too alien, I guess. It's pretty easy to move your applications over.
I think so. And so that's what the SDK does. The SDK also has some ability to do things like, you keep resubmitting if the node is busy. And so it does actually some work for you. It doesn't just create the transaction, but it also does some work for you. It pre-validates it for you in various ways. So it just helps you if you're trying to write software. And that's sort of, I would view, the bottom layer. And then in addition, we have software that we have written and released open source that's really intended like an example, like our wallet software. So we have a wallet software for iOS and for Android. We have a Chrome plugin that allows you to surf the web and be paying for websites as you go to them. We have a plugin then for WordPress that allows you to build a website that will accept such payments, and a payment server for that. We have command line tools that allow you to create transactions from the command line without having to use the SDKs. We have a whole set of tools and things. We're open sourcing all of them. I think some of them are already up on the GitHub on hashgraph.org. And the ones that aren't will be there soon. And so we had that whole ecosystem of tools and so on. And not just us. Other people are doing this as well. So we wrote the SDK in Java, and I think there's a whole bunch of other languages now that have SDKs.
Rust, C, a few others. Yeah. So the community did that. We didn't write those, but we have a big community that's building on top of it. And I'd just like to ask a little bit about HBAR, I guess the cryptocurrency that's also part of Hashgraph, which I think, from very, very brief memory, I think you're using the letter H that comes from Maltese, which is actually a very crypto friendly country, so it's kind of appropriate. From memory, I think I remember seeing that there. So what's the relationship between HBAR and everything else? Does it follow fairly sort of traditional paths of the cryptocurrency and then the networks, or is there something different? What's it with Hedera and Hashgraph?
Yeah, I would say it's pretty traditional.
Okay.
And the symbols are kind of fun. The logo of the company is a capital H with 2 crossbars. And that actually comes from Malta, which is kind of cool.
There you go.
and then the cryptocurrency symbol is a lowercase h with a crossbar through it. And that is a physics symbol. Yeah, so it's Planck's constant divided by 2 pi. So that's kind of cool. The important thing, of course, is that we wanted them to be Unicode symbols so that we could actually easily type it on keyboards and put it in emails and things.
It's a fascinating language, actually. It's a Latinized Arabic. It's a very odd language.
Yeah. Isn't that interesting? That is really interesting. The capital H, the H bar, is really fascinating.
Yeah.
But aside from topology, so it's in many ways a traditional cryptocurrency. It has no inflation. A year ago, we minted all the coins that will exist. You transfer them with transfer commands. You can use the wallet on your phone to send and receive H bars. In a lot of ways, I think it's kind of what you would expect a cryptocurrency on a ledger to be.
Mm-hmm. And how is the I've often noticed that with some DLT/blockchain technologies and their kind of token economics communities, that sometimes the development community and the speculator community can, I don't know, get in each other's way a little bit in terms of priorities and demands. How have you found that kind of synergy between those two sides of your community?
Yeah, so there's lots of people interested for lots of different reasons.
Yeah.
Everyone comes to ledgers with a different goal, a different what they want to get out of it. I think they're kind of broad, and so they just appeal to lots of different people. And so, we see all sorts of different things. We're trying to, build a good system for everybody, for all the different communities. So for developers, we're even looking at using H bars for community development funds and things that will incentivize the community. And it isn't just us. There's an ecosystem growing. So like the Helix incubator is like a VC firm, like an incubator that helps you start up new companies, that is devoted entirely to starting up companies that build on Hedera. And we didn't do it. It just, it did it. I mean, somebody else did it. It's just that the community as a whole is starting to build things like incubators to help companies build on Hedera. So we're just seeing a wide ecosystem, and there's all sorts of different people doing it for various different reasons.
That's a very diplomatic answer. So as far as I can tell, the organization, the company, I'm not 100%. You don't seem to be set up like a foundation as far as I can tell. It doesn't matter too much, but I just wondered.
So technically it's an LLC, Limited Liability Corporation, that LLCs have members, which are sort of the owners. And we will have 39 owners, 39 members. They are term limited. They can only stay for 3 years and then get reelected to a second term. So a total of 6 years, and then they have to leave. We don't want people to get entrenched. We're really trying to keep checks and balances here. That's really the goal. But it is an LLC. They own it. They control it. When they join, they buy their membership for $100, and then when they leave, they get their $100 back. It's not like others where you pay $10 million.
And as far as I can tell, it's existed for at least 2 years. But what's how long have you and others been working on the project, and why did you start it?
Oh, yeah. So really way back in 2012, we started thinking about the problem of how could you do online collaboration in a way that would have good trust? Not really looking at blockchain, because we wanted something fast, and we wanted it to have this ABFT property and be really efficient and so on and be fair. So really looking at it from a different point of view, worked on it for years. In 2015, finally realized how to do it, and that was Hashgraph. And so in 2015, we started a company to build permissioned ledgers on Hashgraph. We didn't want to start with public ledger because we wanted to build trust in the algorithm first. So we created Swirlds, which was a company to get out there this permissioned ledger, and we got customers like CU Ledger. The credit union industry in North America is using it. And so then in 2017, we incorporated and created Hedera. And so Swirlds was doing the private ledgers. Hedera then was to do the public ledger. And we felt at that point there was enough validation that we could get really big council members, like the names you mentioned. We were able to get those. And so then in 2018, early 2018, we had the launch event where we announced to the world, hey, Hedera is a thing. Hedera has these plans. We're going to have a council. We're going to have a cryptocurrency and so on. And then between then and now, we've been building up the council. We've been building the software. We went through a long period of testing. At one point, we had 50,000 people who had accounts or who had profiles in our portal where they would be able to test the network. And after then a long time of testing, we finally had open access where we said, okay, now anyone in the world can use it. And that was what we just had recently.
But what was your actual motivation? What brought you into this world in the first place?
Yeah. The original motivation was that I really want people to be able to interact with the online world, the internet, the cyberspace in a different way than we ever have. It's just too painful. And it still is.
Yeah.
I mean, the whole industry of ledgers is in its infancy. Yeah. But I mean, it really is. But the goal is that you should at some point be able to just, anytime you want, carve out a piece of cyberspace and have your own little world that you can create and then invite other people. And then all of you can collaborate together, but you can trust that the rules of this little world are being enforced, even if you don't trust any particular person who is part of it. And then these little shared worlds should be able to communicate with each other, including public ones that could do things like cryptocurrencies where you just really need a high degree of trust. And they could interoperate with each other and they could send things back and forth. And so you could say, well, this is the ledger blockchain vision on steroids, but it really was coming to that same end state from a different point of view. It was just, how would we like to be able to do this? And you have to have speed, you have to have fairness, you have to have security, and then it all comes down to having trust underneath it all. And so I was just working on that as a fun math problem and eventually was able to find how to do it. I thought it was impossible. I kept convincing myself it was impossible, but it kept gnawing at me. And eventually I realized, oh, you actually can do that. ABFT with fairness and super speed is not impossible. And then from that point, we said, fine, let's bring it to the world. Mm-hmm. And so we've been doing that ever since.
And obviously you've just had a big announcement, but what's next on the roadmap for the next 6 months?
Yeah. So this is where it all begins. So we will be working with partners and with developers to have build this ecosystem on top of us and have it continue to grow. We will continue to improve the underlying system. And so we will be rolling out when we have this beta HCS, but we're rolling out the real HCS. And we have beta mirror nodes. We'll be rolling out real mirror nodes or the full mirror nodes. We'll be doing things like state proofs that are important and making it better in various ways. And just continue to push along, building a big ecosystem on this that takes advantage of its advantages and kind of moves towards this goal of changing the world. I think everybody in this blockchain community, the ledger community, is really seeing how these have the potential to change the world. And that's really what we want to push for. There's just tremendous opportunities for making things more efficient and more trustworthy than they are today.
Okay. And then the final question I always like to ask, just to double check, is there anything important you'd like to make sure you mention that you haven't?
Nothing in particular. I think you've asked really good questions.
And that's invariably the answer, I think, because it's such a broad question.
It is. It's just fun. It has been really gratifying to see the support from the community, to see the network up and running and being used, and to just watch what's happening. And I am really excited to see what's going to happen in the future.
And that was my interview with Leemon Baird of Hedera Hashgraph. I hope you enjoyed the interview. I hope you enjoyed the links. I'll be back from DevCon soon and getting things back on track again. These big conferences always throw my schedule a little bit. In the meantime, you can go to christianschiller.com/writing to find what I've been up to there, and /podcasts for other podcasts, and /newsletters for all my newsletters. And I made some Japan-themed stickers you can also get if you sign one of my newsletters. Next up on my agenda will probably be SDC in Stuttgart. I might go to Web Summit, but I'm not 100% sure yet. But keep an eye on /events if you want to catch up with me there. If you enjoyed the show, please rate, review, and share wherever you found it. And you can also contact me on Twitter @ChrisChinch. But until the next time, thank you very much for listening.